So let's talk about public key encryption. How does it work? Well, first of all, we have to pretend that there's no such thing as subtraction. So if I said to you 7 plus 4 equals, you'd say, oh, that's easy, it's 11. Okay. But if I said, well, 7 plus what equals 11, you'd have no way to figure this out. There's no such thing as subtraction. The only way to get the answer would be to guess. You'd say, well, let's see, is it a 1, 7 plus 1? No. Is it a 2? No. Is it a 3? Oh, it's a 4. So remember, there's no such thing as subtraction. So here's my computer. And here is your computer. And I want to send to you a message. Now I know that when I send a message out here through the internet, anybody can see it. In fact, Darth Vader could be out here spying, and we don't want him to see it. So we decide, okay, we'll use encryption. In order to make encryption work, the first thing we need to do is agree on a key that we'll both use. So that when I encrypt my message with this key, you can then decrypt it using the same key. But I can't just send the key across, because once again, Darth Vader will see it. So here's what we do. I generate a number, a random number, let's say it's a 3, and I call that my private key. I then generate another random number, let's say it's a 5, and we call that my public key. So I take my public key and I send it across, and it's public, so I don't care who sees it. Darth Vader can see it, I don't care. The other thing I do is I combine these two keys together into an 8, and I send that across too. And remember, there's no such thing as subtraction, so Darth Vader can't figure out that my private key is a 3. On your side, you generate a private key. Let's say in your case it's going to be a 7. And what you do is you take my public key, you combine it with your private key, making a 12, and you write that out. And here again, Darth Vader can't figure out that your key is a 7 and mine is a 3 because he can't do subtraction. The other thing you do is you take my combined key, you add it to your private key, 8 plus 7 is a 15, and you save that. On my side, I take your combined key, which is a 12, I add my private key, 12 plus 3 is 15, and I save that. And there you have it. We now both know what the secret key is, it's a 15, and Darth Vader doesn't know. So that's the basic idea behind public key encryption. Now you might say, well, but really there is such a thing as subtraction. But the good news is our friends in mathematics land have created a function that is so fiendishly complicated that once you put two numbers together with it, it's impossible to pull them apart. So they have a function where you combine a 3 and a 5, and you don't get 8. You get some crazy number like 129649. And there's no way to take the 5 out and come up with a 3. The other thing you might say is, well, but really guessing isn't that hard. For a computer, it should be easy to guess these numbers. Well, in this example, the numbers are very small, so yes, it would be very simple to guess. But in real life, these numbers are hundreds of digits long, and even a computer would take years to guess the number. So there you have it, public key encryption, and thank you for watching.